Hi everybody, today we're going to review the order of operations, or as I sometimes like to call it, OOPS, right? Order of operations, right? That was funny. We're going to talk through the order of operations, refine a few things, and then do a few examples. So back in elementary school, back in junior high, you probably talked about PEMDAS, about parentheses, exponents, multiplication, division, addition, subtraction. Sometimes you say, please excuse my dear Aunt Sally, something silly like that, to help you remember the order in which you are supposed to operate when you have a bunch of operations combined together. I'm going to switch that out a little bit. I'm going to change that P, remove it, and make it a G. And the reason for that is, as we get further into math, very often the things we need to put together are not always found by parentheses. They're often found by other forms of grouping symbols. Grouping symbols can be parentheses, but they can be other things as well. So instead of PEMDAS, I'm going to call this GEMDAS. And you remember from the bottom up, addition, subtraction, multiplication, division. E stands for exponents, and now we'll call this G for GEMDAS instead of PEMDAS. Acts sort of the same way, but not every grouping symbol is a parenthesis. You might see parentheses used as a grouping symbol, something like 2 minus parentheses 16 plus 9. And the order of operations, our PEMDAS would tell us to make sure we do what's inside those parentheses before we do anything outside the parentheses, so that's subtraction. So if I simplified here, that would be 2 minus 16 plus 9 is 25. Now I put those parentheses in. I don't really need them once I've simplified inside parentheses. I don't really need them anymore. They're kind of extra. I threw them in there. That's okay. That's 2 minus 25, which is negative 23. But it's also possible you would see something like this. Here's an example, same numbers, but instead of parentheses, we have this square root symbol. That square root symbol is one of our grouping symbols. And when we see that, we should do what's inside that grouping symbol before we do the subtraction. That says the square root of, 2 minus the square root of, 16 plus 9 is 25, and the square root of 25 is 5. This is 2 minus 5, which gives us negative 3. So there's a grouping symbol that is not a parenthesis. That square root takes the same place in the order of precedence in GEMDAS or in PEMDAS that the parentheses do. So be aware of that. There's other forms of grouping symbols. I'll show you a couple more. So here's a problem with a fraction bar, a larger fraction bar. That fraction bar also acts as a grouping symbol. It says we should simplify anything in the numerator of the fraction, simplify anything in the denominator of the fraction, and then divide them. That grouping symbol, I think I mentioned in class last week, that's called a vinculum. Cool word. It acts as a grouping symbol. So this expression is telling us to do 2 minus 16, which is negative 14, and then divide it by 9. Now, in Algebra 1, perfectly okay with improper fractions. I actually like that fraction. If you want to change that to negative 1 and 5/9, that's okay. But negative 14 over 9 is fine. But again, that fraction bar acts as a grouping symbol. Here's a couple of grouping symbols. We have that vinculum, that fraction bar, and we have things in the numerator and in the denominator. So the grouping symbol would say, take those things in the numerator and let's evaluate them. 3 minus 12 is negative 9. Then take the things in the denominator and simplify them. Well, let's see, that would be 4 plus the square root of 4. That's 4 plus 2, and 4 plus 2 is 6. So in our denominator here, we have 6. And we should simplify from there. Both are divisible by 3. So negative 3 over 2. So again, that grouping symbol, the fraction bar, then had to be broken down further because there was another grouping symbol underneath the fraction bar. Another grouping symbol we have are these parallel vertical lines. That's our symbol for absolute value. And the absolute value is also a grouping symbol. This expression would tell us to do 7 minus the absolute value of what's in here. 4 minus 6 is negative 2. When we take the absolute value of negative 2, that actually means that number's distance away from 0 and the absolute value of negative 2 would be 2. Negative 2 is 2 units away from 0. We simplify here, and we get 5. So again, square roots, fraction bars, parentheses, of course, absolute values. We have parentheses. We also have like squiggly brackets or square brackets. All of those things can act as grouping symbols. There may be a few others that I'm missing too, but these will be our big ones for Algebra 1. So those grouping symbols, again, work in the P's place in PEMDAS, but instead of parentheses, we'll just call them G for grouping symbols. So we do those first, then we do any exponents, then we do multiplication and division, and we remember we go from left to right, then any addition or subtraction in the order they appear from left to right. So as we get further and further into math, we've done these little PEMDAS problems, but we're going to get more complicated and more complex as we go through Algebra 1. So let's see. Big grouping symbol. Let me take care of the numerator first. So that's 3 plus 2 squared is 4 minus, now this is square root of 81 plus 19. 81 plus 19 is 100. Square root of 100 is 10, so minus 10. Which in my numerator simplifies to 3 plus 4 is 7, minus 10 is negative 3. Then in the denominator, I have the absolute value of 5 plus 9 minus 15. 5 plus 9 is 14 minus 15. That's the absolute value of negative 1, which is just 1. So my final solution here is negative 3. So order of operations using some more grouping symbols, using some more challenging problems than you probably did in elementary school, and we're going to practice those today. Okay, so again, our big takeaway is that there are other grouping symbols aside from just those parentheses.